move on to thinking about measurement and uncertainty in measurement, significant figures. Some of you, although I know we talked about it in Phys Sci in my class, I assume that significant figures were mentioned in other classes as well, and so you've got a bit of an idea of what we're talking about. It's a funny thing it's a quite Tasmanian approach, but for those of you who are going on in science, then it is an important concept. You would definitely be penalised for incorrect significant figures in chemistry, whereas you may not have been penalised in Phys Sci. In Phys Sci, marking, if you had like 9 significant figures when you should have had 3, you would have lost half a mark. But in chemistry, if you've got if you had 4 or 5, you'd be penalised. Okay? So what are significant figures and what's the big deal? Well, it's all about our ability to measure. So if I've got a beaker with some a solid in there, an ionic salt, and I put it on a set of scales, and just say the reading is 2.56 grams because my scales read to 2 decimal places, then what does that actually tell me about how much of that salt I have? You know, we don't have exactly, necessarily, 2.56 grams. What I know is I have certainty, like these are certain. Those two numbers there are certain. But this one here is uncertain, the last one. Okay, because if I am going to get a reading of 2.56, tells me that this one here is approximately 6. The actual mass could be, it could have been like 2.564, couldn't it, if it was measured to 3 decimal places? Yeah? Because that would be rounded down. Or 2.555 would be rounded up, wouldn't it? So that's why this one's uncertain. Our last one is an approximate value, whereas the other ones are more certain. So that's why we don't want to have too many significant figures in our answer, because we're implying an accuracy of measurement that wasn't true. So if I see this person here and I say, well, I'm going to estimate that they're approximately 1.9 meters tall. Well, that's a reasonable approximation, but I couldn't say, 1.976432 meters, because that would be ridiculous as an estimate. That's attributing an accuracy that just is not true. So that's why when you've done a calculation, if you just write down all the numbers at the end as your answer, with all of just everything, just spew out the numbers from the calculator, it's a bit ridiculous because it's implying an accuracy that just wasn't present. Now, so the way we calculate is we carry all the values in the calculator until the very end. And then we look to see, well, what was given in the question. And we compare then and just say our question, all of the values were to 3 sig figs. Then our answer must be to 3 sig figs after our calculation. As long as we are multiplying or dividing. Okay, Okay, so we use significant figures for multiplication and division, which most of our calculations are. But we do add and subtract. We might be adding masses. So if we're trying to determine the molar mass of a substance, we're going to be adding atomic masses together. And so if we're adding, we are interested in decimal places. And we answer to the least number as given in the question. So anytime we're multiplying and dividing, we're going to be matching the significant figures that were given in the question for our answer. But we don't round throughout the stages of our calculation. But if we're adding or subtracting, then we're interested in the number of decimal places. So what are significant figures? All non-zeros are significant. Any zero in between a non-zero is significant. So 1, 0, 2, 4, 9 has 5 significant figures. Okay, so anything that's non-zero is instantly significant. The 0 here, because it's in the middle of other non-zeros, is also significant. This number also has 5 significant figures because my zeros are at the end. And so I've deliberately included them. This is giving me an idea of the accuracy of my measurement. Okay, so zeros at the end. So where are our, it sounds like they're always significant. Where they're not significant, beginning. Okay, so 0.0042 has 2 sig figs. Okay, so all those zeros before the first non-zero integer, they are not significant. And there's a good reason for that. Because if I, just say I have 42 grams, how would I write that? And I've measured that then. I've measured out 42 grams. How would I write that in kilograms? Right? What would the number be? Yeah. 0.042 kilograms. It's the same number. All those zeros in the front are doing are their placeholders. And it depends on the units I'm using as to whether they're there or not. So that's why they're not significant. They're not really giving me any idea about how accurately I've measured something. It's just a relationship between the number and the units that I'm using. Does anybody have any questions about that? No? You all feel all right about sig figs? All right, you can start working on your questions in the booklet then. 12:30. Oh, is it? Oh. All right. Must be homework then.